Now, before sketching the graph of y equal to x, let's do some observation about y equal to sine x. First one is sine x. We know sine x is a periodic function with the period 2 pi. And it means in every 2 pi, the function repeats itself. And the second thing is sine x is an odd function, which means sine negative x is equal to negative sine x, and which implies its graph is symmetric about the origin. So symmetric about the origin means if you have a point on the graph here, you can do it point wise, and you can also say this: if the graph, one part of the graph is like that, for example, then you can take its symmetry with respect to x, then its symmetry with respect to y. So okay, now we can erase this one. Now this graph is symmetric with respect to origin. So it means if you have a point on the graph and take its reflection through the origin, you will have the other point here. Now its domain is all real numbers and its range is -1 to 1, and in the graph you will see it as the graph continues along the real line, and the range is between -1 and 1, means its graph will be somewhere here between -1 and 1. And the other thing here is the x-intercepts of y equal to sine x is multiples, integer multiples of k pi. So you can see that this way. Okay, what makes y equal to 0? Which x values? Now x clearly pi, 0, and 2 pi, and the others. So when you put them here, you will see 0, y 0. So these are the integer multiples of pi are the x-intercepts of the graph. Now let's make the table of the values for sine x on 0 to pi. So 0 to pi means, 0 to 180 degrees. I mean, you can think of in degrees here, it's 30 degrees, 45, 60 degrees, and 90 degrees, and 120 degrees, 135, 150 degrees, and 180. So then when you put these values inside sine, you will get these values. We already know them. Now in the second quadrant, we know sine is positive, and in the first quadrant it's also positive, as we see on the table here. And now we can plot these points on the Cartesian system, and we can connect the points. Then we will get this one here. Pi is 3.1415. So as you see, pi here is its numerical value 3.41415. So you have to do it. You have to put the point here. So don't think it's equal to 180. So when doing the graph, we don't deal with the degree. And now we know it's symmetric with respect to origin. So what does this mean? We can take this one, take the reflection through the x-axis, and then take the reflection of the reflection with respect to y-axis, so we will get the other part of the graph. So if the graph is symmetric with respect to origin, it has this property. Now by doing that, we get the graph of sine x from pi. Okay, here it's pi, and here it will be minus pi. And as you see, we get the picture of sine x, the graph of sine x, in an interval of 2 pi, which is the period of sine x. And we can extend this piece of the graph, like we can extend the graph this way, like take this one, we already got that part, from minus pi to pi. And then since it's one full period here, one full period graph, so it's 2 pi length, okay? So it means you can make the copies of it because the function repeats itself. So now you will get pi here, and it will be 3 pi here. It's about 9 point something. Yeah, and then you can make the other copies as well, like that. And one other thing here I want to tell you is you can take any picture of 2 pi length. So take the picture from 0 to 2 pi, for example. It's up to here, so 0 to 2 pi. Now you can take this picture, you can take this frame of the graph, and then you can make the copies, like, because this is 2 pi, and now you can put the same thing here, and you will get the same graph. So you can take this one and you can repeat it here as from 0 to minus 2 pi, and you will get this, you know. So any 2 pi length window is okay to copy or to extend the graph, okay? Now, you have to have this in your mind, like the behavior of sine x, between minus pi and pi, around 0. So at minus pi, we have 0 negative sine pi is 0, sine negative pi over 2 is minus 1, sine 0 is 0, sine pi over 2 is 0, 1, and sine pi is 1. So you have to have this graph, a quick graph, in your mind. So I can say memorize it, or just memorize the values of sine minus pi and sine minus pi over 2. You can say this is sine pi, which makes 0, and this makes here sine pi over 2, and it makes 1. Only if you know only this part, you can do with the symmetry, this part. Now let's talk about the amplitude. The amplitude is telling us the depth and the height of a wave. So here you can say this is a wave. Wave means here moja. So this will be the height of the wave, and this will be the depth of the wave. But together, we will call them height. Sometimes it will be height, sometimes depth. This is the behavior of the wave. So we will call them together amplitude. So the amplitude here, the amplitude of A sine x, is telling us how high and how low the graph can be. Now this here, the absolute value of A, is called the amplitude. So it determines how high it will go and how low it will go. But we are taking the absolute value. The amplitude is always positive. So amplitude always positive. Now graphing y is equal to A sine bx. Now let's see the strategy for graphing such function. Now we will assume b here inside is positive, because even it's negative, you can take this negative out. Negative sine 2x, for example, it's minus sine 2x. So we end up with something with b bigger than 0. So minus value is not an important issue. We can take it out. Now the strategy is this. Find the amplitude and the period first. And how do you find the amplitude? You just take the absolute value of A. And how do you take the period? The period of sine is 2 pi. And we divide it by the the coefficient of x, so the period will be 2 pi over b. And divide the period into 4 subintervals of equal lengths. So what are we trying to do is like we are trying to get the behavior of the function from 0 to 2 pi over b, and we want to do some more on these points. Like we want to get the table for this part, then once we find the points, then we will make the graph. So for this reason, we'll find the points on this interval. So, and then we will make a table with these values, and then we will plot the points, and then we will connect the points, and then extend the graph by using the period. We can make the copies using the period. Now let's look at this function. So let's sketch the graph of y equal to 3 sine 2x. The first thing we can see is the amplitude here is 3. You take the absolute value, and then the period of sine 2x is 2 pi, which comes from sine, and 2 comes from here, the coefficient of x, so it will be 2 pi over 2, which is pi. Then next is you divide the period into 4 steps, like pi over 4, and make a table by starting from 0 to pi by using pi over 4. So indeed, these 2 steps are doing this. So you start with 0 and you end pi, and now you're trying to find the points here, 2 or 3 extra points here. So what we do here is 0 here, pi is here, then you divide them into 2, just so you get pi over 2 here, and then again you divide it by 2, so you get pi over 4. And then you take the average of these, you find the midpoint, you find it this way. Now it will be 3 pi over 4. Now these are the points we have. Now by using them, we will make the table by using these points. So this is this step 1 and step 2 is telling you how to get these. Like either you can do like half, or you can directly do like pi and pi over 4 divided by pi over 4. So you will get like pi over 4, and this one will be 2 times pi over 4. This one will be 3 times pi over 4, and this one will be like 4 pi over 4. So you can do both ways, but the idea is to get the numbers in the middle. Now then, after this, we take these x values and we put them here, you put them here, you get these values. Now after these values, okay, you can try to get these values. If you know the values, the certain values of sine, it shouldn't be a problem. You can do it without calculator. At least your knowledge should be enough for this. And then draw, plot the points here, 0, 0, and 3, pi over 4, 3, and pi over 2, 0, and the rest. Now 0, 0 is here, and then pi over 4 is 3 is here, and then pi over 2, 0 is here. Now after this, you will connect the pieces here. Sorry, connect the points, so it will be a sinusoidal curve. Sinusoidal means like wave. Okay, and then the next thing is we have to extend it by using this period. So here, we made a picture of only one period here. And then you can make the copies to the other intervals of pi length. So then it will show you the whole graph, but it doesn't end here. So you see the arrows. The arrows are saying so it continues, by the way. Okay, now let's look at this try and check exercise. Okay, I will try to do it quickly here, and I will write it here. The first step is the amplitude is 2. I'm taking the absolute value of -2, it's 2. And the period is what? The period is 2 pi over pi, which is 2. Now step 2 is making the points. We know the points will start and end at 2, and then make the half. It's 1 over, it's 1 here, and then you can say 3 over 2, and this is like 1 over 2. So we make 5 points. We know the end points 0 and 2, and you look at the halves. Step 3, and by using them, like make the table. Okay, make the table 0, 1 over 2, and 1, 3 over 2, and 2. And then sine x will be, okay, -2, sine x will be, pi x will be, okay, then put these values here, you will get 0, and you will get -2, you will get 0, you will get, okay, if you don't understand this part, please stop the video and try to calculate these, okay, because this is important. You should be able to do it by yourself. So without calculator, you should be able to do it. You know, these are important here, so we'll get 0 again. Now I can show you, for example, how to get this one. So -2 times sine pi times 3 over 2, and this, if you change it to degree, it will be sine 270. And how can you get the sine 270? So I will do 270, and I will use okay, I will use the unit circle. You know, the unit circle, if I use it, will be like a -1. So no, so 0, -1, and this will correspond to cosine 270, and this will correspond to sine 270. So sine 270 is -1 here, so -2 times -1, it will be 2. So I got this one as 2. So you should be able to do this calculation, okay, without a calculator. You can use the unit circle for this type of angles. Sometimes we use reference angle for the other type angles, but if the angles are on the x-axis or on the y-axis, we use unit circle. Now we plot the points on the xy system, 0, 0, and 1 over 2, -2, and then 1, 0, and then 2, 3 over 2, 3 over 2, 2, and we have 0. So you can do this way. So it's better you write them here. Sorry, this is 1. So this will be like 1 over 2, and this will be -2. This will be like 2. Okay, so then you will, okay, this is one full period, you know, picture. You can make the copies of it, and so you will make the copies, and it will be the graph of it. Now let's see how to graph y equal to a cosine bx. Now let's do some observations about y equal to cosine x before sketching the graph. The first one is it's periodic with the period 2 pi, and it's an even function. So even function means cosine minus x is equal to cosine x. So it means it's symmetric with respect to y-axis, symmetric about the y-axis. It means if its behavior here like that, it will be the same thing here. And its domain is all real numbers, and its range is -1 to 1. So it means its graph will continue along the x-axis or along the real line, and its height will be between -1 and 1. So it will go like this. And its intercepts are the odd multiples of pi over 2. What does this mean? Okay, it means like at these values cosine is 0. So take k equal to 0, for example, you will get pi over 2 here. If k is equal to 0, then you got cosine pi over 2 is 0. So if you take k equal to 1, then you will have 3 pi over 2, so which is also 0. And if you take minus 1, okay, minus 1, you will get cosine, okay, minus 1 here, it will be minus pi over 2. Then again, this will be equal to 0. So for all these k's, at these x values, the cosine function is equal to 0. Okay, after these, we can make the table by plotting some points. So let's first, let's first find the points. Okay, now from 0 to pi, I will concentrate on 0 to pi first, and we know the values between 0 to pi, 0 and pi. Here 0, it's 30 degrees. Here it's 45 degrees and 60 degrees. These are the well-known angles, as you know. And this will be like 120 and 135 and 150. By using the reference angle, you can find them. And this one by the unit circle, you can find this one. By unit circle, you can find this one here, 180. Now the rest you can do the reference angles, and you will see cosine is positive in the first quadrant and negative in the second quadrant. Then when you plot these points on the graph, you will have such thing. And the next thing you have to do is use the symmetry with respect to y-axis, because we know the cosine function, the graph of cosine function is symmetric with respect to y-axis. So now we can make the, okay, we got this one. Now we can make the symmetry with respect to y, so we'll get the other part. So when you get the other part, then your graph will be from negative pi to negative pi to pi. So this is pi up to pi, and this is up to negative pi. So you will have this graph. So this is the graph of cosine x. And the main difference here is, the biggest difference from sine is sine passes through here, but cosine passes through 1. So this is an important property here. So it doesn't pass through the origin cosine function. Now, how can we extend it? We can take any, we can take the picture, our picture, between minus pi to pi, so it will be like 2 pi length picture graph, and 2 pi is a 1 full period, right? So it's 1 period is 2 pi. So if you get a window of 2 pi length, then you can make the copy of it, and you will get the rest of the graph. And again, to copy any length of 2 pi window, any window of length 2 pi is fine. So you can take this one here and take this one. Now it will be like 2 pi here, 2 pi length. You can take this one, and then you can make the copy here. So it will be something like this. Now you can make the copy this way. So any length, any window of length, okay, 2 pi can be copied. Okay, then you can form the graph of cosine x. But the most important here is, the most important thing, you have to remember the graph of cosine x between minus pi and pi. So it's like a bell curve here, bell curve around 0. We can say something like a bell curve, an approximate will be like that. So it goes up to 1, and the ends are going to 1. So it's like a bell curve. And as I said earlier, so this is the main difference between cosine and sine. Cosine is 0, cosine 0 is 1 here, but sine is 0. Sine is passing always through the origin. Now again, let's talk about the amplitude. The amplitude is the absolute value of A. So the amplitude is giving you the height or the depth here. And we can now let's see how to graph y equal to a cosine bx. So we will take b bigger than 0. As I said earlier, even you have like this, you know, minus, or you can use the evenness of cosine, and you can say it's plus 2x because the cosine is even. Now the strategy is similar to the sine. So you find the amplitude and the period. Okay, where do we use the amplitude? You know, you can check the amplitude like in the multiple choice questions. Like you can directly go ahead and which choice doesn't have an amplitude A, so you can eliminate this one. Anyway, so this period, you find it, the period is 2 pi over b, you know, and you divide it into intervals. So basically you're trying to make the points for the table. So it's 0, 2 pi over b, and then the half of it, and then the half of it. So it will be 4 then. So it will be 2 pi over b over, okay, so how do you get this part here? And this is equal to that. And but here this one will be like 2 pi over 2b plus 2 pi over b divided by 2. So you add these two and divide by 2, so you will get this one. Most of the time, if b is a good number, this shouldn't be a problem, you know, finding these points. But if you get confused, we provide you a method here. You can directly you can take this 2 pi over b divided by 2, so it will be pi over b. And no, sorry, this is you have to divide by 4 and then multiply it with 0 and 1 and 2 and 3 and 4. You will get all these points here by doing this. Starting from 0, you will get, and then you're ending with 2 pi over b. Okay, then you make the table and you plot the points from the table, and then they extend the graph, and that's it. Now let's graph y equal to negative 2 cosine 1 over 3x. Now let's start with this. The amplitude is 2, and the period is 2 pi over b. It's b is 1 over 3, so it will be 6 pi. So 6 pi. You can divide the period 6 pi. Sorry, it's 6 pi here. 6 pi into 4 equal lengths. Like here, basically step 2 is saying, okay, you start from 0 and you make this 6 pi and you divide it into 4 intervals. So you want to find the points indeed. Like you can directly say it's 3 pi. This is 3 pi over 2, and this is what is the middle between them? It's 9 pi over 2. So this steps, I mean, these two steps here are telling you to find this. You know, you can directly do like 0 and 6 pi, and then, you know, make the half, and then look at the half points, the midpoints between these numbers. And then after this, I mean, you have to put these numbers to the table, and then after this, you have to find the values of these. Okay, put 0, you got cosine 1 over 3, 0, which makes cosine 0, so it will be 1. So it will be minus 2 then. Okay, then when you put 3 pi over 2, you know, you will try, okay, you will have pi over 2, cosine pi over 2 is 0, and then we will have this. And you can do the others, like you will get, if you put this one cosine, you will get cosine pi, and which will give you -2, -1, so it will be +2. You can do the rest, I mean, check them. I mean, if you have difficulty here, please pay attention to this issue and try to learn them. You can go back to the previous chapters and the previous sections to find them. Then the next thing here is we plot these points on the xy system. So 0, -2, and then 3 pi over 2, 0, and then 3 pi 2, and then 9 pi over 2, 0, and then 6 pi over 6 pi -2. And then you connect the pieces. I mean, you connect the points, then you got one full interval graph. So this is 6 pi as you see. And now you can take the window here or take the frame and you can extend it. Now it will go like this. You can extend it. And here, of course, the graph doesn't stop anywhere, so we use these arrows are telling you it doesn't stop, it continues. Now let's look at the try and check exercise. Now let's see what happens. The amplitude is 2 for sure. Okay, I will do it here. And the step 1 is the amplitude is, so I will say the amplitude is 2. And I will get the period is 2 pi, so which is coming from the cosine. And the coefficient of x is 2 pi, so we will get 1. Now, we found them. The next is do step 2. Step 2 is you divide, okay, you start from 0 and go to 1. And then find the points here, the quarter points, like 0, 1 will be 1 over 2. And then you divide by 2, it's 1 over 4, and this will be 3 over 4. Now the next step is we got the points on the table. So 0, 1 over 4. No, I would do the table. These are the x values. Now you have to put these values inside cosine 2 pi x. This will be 2, and if this is a cosine function, indeed, like depending on the first one, it starts always 2 like this one, and it goes like the other one goes like 0. I mean, you can put this 1 over 4 here, so 2 pi over 4, so you will get this cosine pi over 2, and this will be 0. So this, obviously, this is 0. I mean, you can check. I recommend you all plug the values because I don't want to spend time on it. So put them in here and do the see the value. So this will be -2, and this will be 0, and this will be again 2. And then step 4 is you're doing you're plotting the points now 0, 2, and 1 over 4, 0, and then 1 over 2 like -2. Sorry, this -2 is here, and then okay, maybe I should do them with another color. So at here, and then at 3 over 4 will be 0 again, and then at 1 it will have 2 again. So it will be something like this. Now this will be one window, one period window, and if you want to extend it, you will do another window of the same period, I mean same length. This is one here, and do another one. So you make the copies. and it will be your graph. This will be the graph. Okay, the more points you take, and it will be nice, better graph. But I think these are okay. Now, in here, so in here we'll try to determine a sinusoidal function from its graph. So this time, the graph will be given to you, given to us. Then we will try to get a function here. What is f of x? So we will try to get, when it says sinusoidal, so it means like it's either cosine or sine graph. So we will see some stretching or shrinking of cosine and sine function vertically or horizontally. We don't look at the shifts, okay, the vertical or horizontal, so we don't look at them in this section. Now basically we will concentrate on finding a function of this type. So since it's sinusoidal, so we will be looking at cosine bx or a sine bx or a sine bx, both. Okay. Now the first thing is find. Okay, you can read this one like choose two consecutive top points from the graph and measure the distance between them. Consecutive means next to each other. So here, these are next to each other. So we will choose these two, not three of them. So this will give you the distance here. So we check the distance. So this distance will give you the period. Or you can choose the bottom points, the consecutive bottom points here. It will give you the period also. And then after this, we will find a b. So either this is cosine bx or a sine bx. What is the period? In both, the calculation of the period is easy. It's 2 pi over b. Now the period now is coming from the graph. So from the graph, you find b, then you set it equal to 2 pi over b, and then you obtain b as 2 pi over the period. This is from the graph. Now we end up with b. We don't know if it is cosine or sine, but we know the b. Now the amplitude of absolute value of a is the y component of the top point of the graph. So when you look at here, the top points, this will give you the a will be this one here. So the y components, no matter what these values are, the x values, I can say x1, x2. The second component will be definitely the amplitude, the absolute value of a. We know it's the height, so it makes sense. So we have some idea about the absolute value of a now, because a might be 0. A might be negative or positive. So the y. So here are the criteria now. The y, if y-intercept of the graph is non-zero and positive, f is cosine function, and a is bigger than 0. And we have, if it is non-zero and negative, it's cosine function, and a is less than 0. So what does this 2 mean? Okay, I will show you directly here. In the graph. Like if you have such thing, then you have a. You say a is bigger than 0, and this is the graph of a cosine bx for sure. Now it says if it is like that and a here. So again, this is y equal to a cosine bx. Now, as you know, a is less than 0, so because it's here, because it's under the x-axis. Now the point here is, okay, if I put them together, we have two cases for cosine. Either you have this one if it is a, or if this is a, in both cases, might be this one or this one. At 0, they take, the values a, or, a minus a. So, I mean, a values. So f of x is definitely a cosine bx. So we need to say it's cosine. It will be cosine. Now, when it comes to the sine, so for the sine, we have this situation. For sine, if it goes like this, or if it goes like this, so it passes through the origin. So you say this is the function here is f of x equal to a sine bx. So here you will see it's increasing. A is bigger than 0, and if a is less than 0, it's a decreasing function here. But these passing through the origin is definitely telling you sine x. So origin implies sine x, okay? Not origin implies cosine, okay? Cosine, definitely. Sine, cosine. What's the difference? Not origin, it's not passing through the origin, but sine is always passing through the origin. So these are the two important things you have to know. Stop the video and draw it somewhere. Now the next thing is so it's telling about the sine function. Now this is what I'm telling about these. Now let's do this example. In this example, okay, I will try to show you the details here. I think it's hard to see. 1, 2, 3, 4. It goes like this is a pi 3. And okay, what else? This is 3 here. Okay, I think you can guess the rest. This is easy then. Okay, find the equation for the graph. We can follow the steps here. We can go with the period and the amplitude here. What's the amplitude or the period? Okay, let's start with the period. The period from the graph, it will be the distance between 0, 3 and pi 3. What's the distance here? So it will be like here pi. This is 0, so what's the distance? You'll see the distance is pi, so the period is pi. Now then, if either it's cosine bx or sine bx, we don't know which one yet, but we are sure the period should be equal to 2 pi over b. So then you set them equal to each other and you find pi equal to 2 pi over b, and then you find b is equal to 1 over 2. No, sorry, this is b is equal to 2. Then you can do the calculation. Now, after getting b, you can decide which function is it. And which function is it? This function is definitely a cosine function. You see, this is cosine. So we know 2, b is 2, we found it. And what is a? A is directly the top point here, which is 3. So you can directly say it's 3 cosine 2x. And there are other ways to find it. Now let's follow the slide. Let's see what's next. This is cosine and sine, definitely. It's a Mauger wave. And the distance between these two guys are, these 2 points are, we know, here pi. So this is telling you this. Now using the relation p is equal to 2 pi over b, and then you set it, so you set equal to this one equal to pi, and then b is equal to 2. And the y-intercept of the graph is 3. So then we conclude this function is a cosine function, and a is directly 3. Now let's do the try and check. Okay, I'm not sure if, okay, if we can see. Okay, these are like minus 3, 3. This point is 3, 3. Okay, these points are like 2, 4, 6, 8. It goes like this because this is 3 here. Yeah, these are like minus 2 and minus 4. It goes like this. Okay, yeah. Now, we want to find the equation for it. One thing you can say here is the distance, this distance between two top points, and the period now is 3. Okay, here's minus 3 and here is 3. I mean, then you can say this one is 6, so the period is 6, and it's also equal to 2 pi over b. You know, in this type of questions, we definitely know, okay, for sure that this is important. We definitely know that it will be something like a cosine bx, okay, or a sine bx. I mean, we are doing all these methods, you know, assuming our function is a cosine bx or a sine bx. Otherwise, you cannot follow the methods here. I mean, we can maybe, but you have to be careful about the other transformations. If there's another transformation happened in the graph, so these steps, in these steps, you will not be able to see them. So, okay. And we know that the period is 2 pi over b, and also it is equal to 6. We know from the graph. So we know it from the graph. So you calculate, roll the 2 pi over 6, so which is pi over 3. Like after the cancellation, you will get. So we know it's 2 pi over 3 b. And is this a cosine function or sine function? Now this is not passing through origin, not passing through origin. So it's definitely cosine. So now we will end up with a times cosine pi over 3 x. Now what is a? What is a? A here is negative 3, right? This here. You can directly say it's negative 3 times cosine pi over 3 times x. Because when you plug 0, you will get a is equal to negative 3 here. Now, let's see how to sketch the graph of tangent. So first, let's do some observations here. Tangent x is periodic with the period pi. First, we know it. And then tangent is odd function. The odd function has a symmetric graph, which is symmetric about the origin. So it means if this part is given, then you can do this. You can do the reflection through the y and then through the x and through the x and through the y-axis. So you will get the second piece here. Okay. And the other thing is, okay, its domain is all real numbers except odd multiples of pi over 2. So we have to be careful because its tangent is undefined for pi over 2 and 3 pi over 2 and minus pi over 2. You know, they're all undefined. Now at these points, you cannot find a point on the graph corresponding to these x values. Now that's an interesting property here, and this is normal for tangent. So when you take Okay, you can read here, but what it says here is this. It says when you take very close values to 90 degrees, which is pi over 2, so you will get huge numbers. So this one, I mean, in terms of degree, if you write it to calculator, it's about 52 million. So the tangent values are getting very, very big, okay? And if you make it like very close to, okay, from the left side, if you approach 90 from this side, you will have a blow up values, like very big values. But if you make, if you approach it from the left, you will get minus 52 million, something like that. So you will have values on this part. If you approach, like, you will get the points like here, very, very low points. And okay, now I recommend you stop the video and try to do, okay, please try to do such calculations. Okay, see if your calculator, so see what it gives, the calculator gives, and try to make them very, very close to 90. So see with the calculator, because experiments will teach you better than, you know, these words. These, okay, we will tell it to you, but you will not understand maybe. But if you do the experiments with the calculator, you will definitely get the idea. I mean, also, you can use Desmos.com. Sometimes I use this to graph the functions. So then do the experiments, and you can check your calculations and the graphs by using this website. It's a quite useful website, and it's pretty easy to use. Okay, then we will come to the vertical asymptote issue again. But anyway, we will see it in the graph. It's better we see it on the graph. Now let's start with 0 to pi over 2. Let's take the points from 0 to pi, and between the 0 and pi over 2. And pi over 2 is not included, as you know. This is because at pi over 2 and its odd multiples, the function is undefined. Now let's take, this is 90 degrees, as we know. This is 0, so you take 0, 30 degrees, and 45 degrees, and 60 degrees. If you have a calculator, you can do more. You can take more values, but since we are not allowed to use calculator, we take only the special angles we know, and we know their values. Tangent 0 is this, tangent 30 is this, and tangent 45 is 1, tangent 60 is square root 3, and then we put them on the graph. So at 0 it will be 0, 0, and at pi over 6 it will be like that, pi over 4 and pi over 3. And if you take, so this is what I mean, if you take close values to pi over 2, you will get big, very big numbers. So this will kind of blow up. We call it blow up here. It's a blow up here. Blow up means like it goes high immediately. It goes high immediately. Not as smooth and slow, you know, increase. Just very high increase, very fast increase. Now we can use the symmetry with respect to origin. The tangent is odd, and the symmetric with respect to origin. What will you do here is, to get the other part, you will take this and you will take this one, and you will get the other part. So if you get the other part, you will get this. Now here we, okay, let's pay attention to pi over 2 and negative pi over 2. So these are called the asymptotes. Sorry, this is x equal to pi over 2, and this x equal to minus pi over 2. And these are called the vertical asymptotes of tangent x. Are these the only ones? No, we will see them. We will see all of them. But now the around 0, these are the ones we have. The vertical asymptote means the function is approaching to this line, but never touching. So it gets closer and closer and closer, but never touches. Okay, so these are called the vertical asymptotes. Now we got, okay, and also I want you to remember this: the period of tangent is pi, as we know, and we got a window of pi length. So then we can make a copy of it. So we take the pi length window and we copy it. So this is one full period. So if you get one full period picture, then copy. Then copy. So then you will copy, and then it will go forever. So the graph of the function doesn't stop anywhere. But at this point, as you see, at the odd multiples of pi over 2, the function doesn't have any point corresponding to these values. Okay, so it means the graph is not touching the line, touching the asymptotes. Okay, and here, these are the periods as you see here. The lengths are the length between two consecutive vertical asymptote is the period. Now let's see how to graph this type functions a tangent bx. Here is a strategy. Again, we will take the positive b values, because when I say tangent negative 2x, it will be minus tangent 2x because of the oddness of tangent function. So in any case, we will have a positive number here. So it's not important. Okay. Now, first you calculate the period, and here there is no amplitude. No amplitude for tangent x, by the way. We don't say it's this a is amplitude or not, because the amplitude is giving the height. What's the height? So the height is infinity. So you cannot take it as an amplitude, okay? So it's a periodic function, but it's not sinusoidal. Okay, first you find the period of tangent is pi, and the coefficient of x is b, so we calculate the period as pi over b. And then, this is an important step for tangent only, you find two vertical asymptotes. This how you divide by 2, divide the period by 2, and then make plus and make minus here, and you will get these asymptotes. You know, the asymptotes, the vertical asymptotes, always in this type, like x equal to something. So you see this is one asymptote, and the other asymptote is pi over 2b. Okay, one of them is minus, the other is plus, by the way. Minus, the other one is plus. Now, then we divide this interval into 2. So this is 1 point here, and this is 1 point. Now we will use the table. I mean, when doing the table, you have to find a point here. So what is between them? What's the midpoint between them? Add them, divide by 2, you'll get 0. And now what's the midpoint between these two? And that will be minus pi over 2b divided by 2. And in the same way, you can say it's pi over 2b divided by 2. So you find these points, then you will put them on the table. So you put them on the table. This is 0, starting from 0, and it ends with 2 pi over 2b. No, not 0. Minus pi over 2b, and this is 0. Okay, you put these values, and you will find the y values, and the rest is easy. Now, okay, step 3 is telling you. Step 3 is telling you to make a table and telling you how to find these points. Okay, and after this, you plot the points from the table, and then yeah, your values will tell you if it is increased or not. So you don't have to pay attention to that much, but this information here, this information may be good for, you know, multiple choice problems, good for multiple choice problems. But you know, when doing the when making the table, I mean, when we do the table, we will see the behavior of the function if it increases or decreases. But anyway, this is a shortcut information. Now let's look at the graph of this on this interval. -3 tangent 2x on the interval minus pi over 2 and pi over 2. Now let's do this example, and we will graph y equal to -3 tangent 2x on the interval minus pi over 2 and pi over 2. Okay, let's start. The first thing we can do is what is a and b? A is definitely -3 and b is 2. And then find the period. The period is pi over 2. And you can start, okay, the next thing for tangent is to find the vertical asymptotes. How do you find them? You divide this by 2, divide by 2, say x equal to, and one of them is plus, and plus the other one is minus. So these will give you the vertical asymptotes. Now you will see them. Now the vertical asymptotes, just divide this, divide the period by 2. Like, you can use the formula as you wish, I mean, as you like, but you know, the idea is divide by 2, divide the period by 2, and plus minus. Okay, you will get these values. Now then we have, okay, for these points, we have the asymptotes. What is this point? This is x equal to minus pi over 4, and this makes the line. X equal to pi over 4 is the line here. And now we divide this interval into 4 equal sub-intervals, let's say. Okay, minus pi over 2, then pi over 4, and this is pi over 4. So basically we are trying to make the table, and we are choosing the points for the table. Just between the midpoint between pi over 4 and the negative pi over 4 is 0. And what is the midpoint between these two? It will be negative pi over 4 over 2. And here it will be negative pi over, so plus pi over 4 divided by 2, which gives us negative pi over 8, which gives us pi over 8. So we will get negative pi over 4, negative pi over 8, 0, and pi over 4. So you can do it, but if you want to use this one here, pi over 8, and then you say minus 2 times pi over 8, it's 1 times pi over 8, and then 0 times pi over 8. You can use the multiples of pi over 8, 1 times pi over 8, and this will be like 2 times pi over 8. But the idea is this: make the quarter points between the vertical asymptotes. Now after doing this, what we get here is these values. So they're corresponding to these x values here. So now we want to find them. Okay, there's a mistake here. The mistake here is this is minus. Okay, so because this has to be minus. Now when you put negative pi over 4, you can put it here. So this will be -3 tangent negative. So this will be undefined. And you can put minus pi over 8 here, and this will give us minus pi over 4, and it will be now you take this minus out, so it will be minus tangent pi over 4, and which is 1. Tangent 45 is 1, so you will get -3 times -1 plus 3, so you will get this one. Now all these values can be calculated by substituting these numbers for x in the function. Now once you get them, Okay, after finding the graph of the function on a full period, which is here pi over 2 length, now then we can make the copies of the graph, and it will go like this, and here it will go like that. You can make the copies, but the thing is we will cut the graphs from minus pi over 2y, because it says in the question it says graph on minus pi over 2 and pi over 2. X's will be between minus pi over 2 and pi over 2. So it means you will cut the graph, you will take this piece of the graph. So then we don't need to show the other parts. This is why we are showing this part of the graph, minus pi over 2 to pi over 2. Okay, let's look at the try and check exercise. Now, graph one full period of y equal to tangent 0.5x. So let's start with the period. So what's the period of this pi over 0.5, which is 2 pi. I leave it to you why it's 2 pi. You calculate. Stop the video and try to calculate. Good exercise for fractions. Now p is equal to 2 pi. That's one thing. Okay. The second thing is we will find the vertical asymptotes. At least the first. Okay. How many asymptotes are there? Infinitely many, but the first two asymptotes, I will say. First two asymptotes are x equal to minus pi and x equal to pi. So how do you do it? Like you divide 2 pi over 2, you divide by 2, you will get these. And okay, then 3. Okay, now I will put this here. For sure, I will get minus pi here and pi here. And okay, these are the vertical asymptotes, as we know. And we find the points here, minus pi and pi. Find the table values. Between them it will be 0 for sure. And in between them it will be minus pi over 2 and this is pi over 2. So they will make the x values. And we have to find the y values now. So y values, you put them here. You put here minus pi over 2. So then you will get tangent minus pi over 2. Okay, this will give you undefined. And when you put this here, this one, you will see it's minus 2. And when you put this here, you will get, okay, I forgot 0 here. So 0, when you put 0, you will get 0. And pi over 2, it will be 2. And here it will be undefined. So when you put these points at minus pi over 2, you get minus 2. And at pi over 2, you get 2. Then now it's clear, like 0, 0, it's always there. So you have to have this type of graph. So this will be just one full period graph. So the period is 2 pi. Now let's determine the function, a periodic function of the form a equal to tangent bx from its graph. So basically, if it's not like this, so which is sinusoidal graph, so cosine or sine, if it is not this way, and if it is, it has vertical asymptotes like this, or it has behavior, no, not like that. So it's a similar behavior all the time. With the vertical asymptotes, it will give you a tangent function. then you can use this tangent function to specify its formula. Now, the first step is you will find the period and the period of, okay, now our assumption is this is important in this type of things. Like when we teach you the steps here, we assume the graph is this type function, okay? If the graph is, I mean, these steps we teach you just to find this type of function. And in general, it doesn't have to be like that. So someone can give you like a graph, something like this, you know. So definitely, we don't take this -5 into account. Okay, so if we cannot find the function, this type of function from the graph, because we are teaching you if the graph belongs to a function of this type. Okay, if the graph is given, if we know the graph belongs to some type of tangent bx, now first we find the period from the graph. Find the period from the graph. Okay, then pi is equal to p is equal to the period is p over b, you know, if it is tangent bx. So this is the period, how you get it. And from the graph you got the p, so you set them equal to each other. This is from the period, and from the formula we get this one, and then from this we find b is equal to pi over p. And then the next thing is find the point on the graph whose component is x equal to pi over 4b, and then y component, this point is equal to a. So here's the idea here. Why are we doing this? Like if you put b times x as like pi over 4b, then you will get like tangent, sorry, this it will be 4. So tangent pi, or this will be 1, so you will get the value a. So the y component will be equal to the a value. Indeed, you can put other points, it doesn't have to be like pi over 4b, but you can put the other points and see the a, I mean find the a. And you can also determine whether a is negative or positive. Now here, so if a is bigger than 0, so it will go like this, but if a is less than 0, so it will go like this. Basically telling you this two shapes here. If a is bigger than 0, you will have such thing, and if a is less than 0, your shape will be something like this. You know, there's a difference between them. Now let's find the equation for the graph. Okay, this is hard to see, but I will write here a is equal to pi over 2 minus 4, and it passes through tangent. Tangent always passes through 0, 0, definitely. And here, okay, this is minus pi. This is pi. So you can tell, you know, the period from here, right? The period is what? Period is 2 pi for sure. Okay, we know the period from the picture, it's 2 pi. And we know a point, this is pi over 2 negative 4. And from here you can say pi. Okay, the first thing maybe you should say is we have this type of behavior, so this is a times tangent bx function. Now the period of this function will be pi over b, and which is equal to 2 pi, and then you will get b is equal to 1 over 2. And then you will have a times tangent 1 over 2x. And what is the next thing? A. How can you find a? You plot the point, I mean you will substitute the point here. Y is equal to negative 4 and then a is equal to tangent over 2x, which is pi over 2, and then it will be minus 4 is equal to a tangent pi over 4. This is 1, so a will be equal to minus 4. Okay, let's see. Let's follow the slides. Now it says there are vertical asymptotes on the graph, so we conclude it's a tangent function. So it has this type of behavior. So it's repeated, and we have these vertical asymptotes. So it's a y is equal to tangent bx. And then the next thing is we look at the distance between these the two consecutive asymptotes. It's 2 pi. And we say pi over b is equal to 2 pi. And then you find b. B is 1 over 2. And the next thing here is to find the value, you can use that point here. This is given to us. And you say x equal to pi over 2. When x is equal to pi over 2, and then y has to be minus 4. And then you put these on the graph, on the function here. The function indeed is like a times tangent 0.5x. So you put here x, pi over 2, here y, negative 4. Then you will get a. Then it will be negative 4. A is equal to negative 4. So our graph will be, the equation will be y equal to negative 4 tangent 0.5x. To have a good understanding of this topic, please do the additional exercises. And also you can do some experiments. Do experiments with graphing calculator or the website desmos.com. You can make the graphs. You can see how does it change, what changes the graphs, and how does it affect the period and the other stuff. Then you will have a good